Welcome to the Practical Data Community Lunch and Learn. So very fortunate to have Elias Defaria today from DBT Labs. We're going to talk about DBT Fusion and I guess whatever else you want to talk about. So I think we saw each other last month when Fusion was unveiled, and we've been meaning to organize this lunch and learn for a while. So here we are. I'll let you kick things off, Elias.
Awesome. Yeah, thanks, Joe. Thanks for having me. It's excited to talk about Fusion a bit. And I also want to make this as sort of interactive as possible. So if anybody wants to chime in at any point with a question, feel free to just interrupt me during either the presentation or the demo. But I will, I'm seeing a small network issue on my end. Joe, can you still hear me well? Am I good?
You can hear you just fine. Yep.
Awesome. Okay. Yeah, I was just saying, so feel free to interrupt me whenever. I'd love to make this really conversational as opposed to like a full presentation type thing. That being said, I do have a presentation, so I'll go ahead and kick off with that. So I'm going to share my full screen here, and let's do it. Can you all see my screen? Can you see this deck I'm showing?
Yep.
Great. Okay, so we're going to talk about specifically today the Fusion engine, which many of you probably have heard about, and sort of how it really, I think, levels up the developer experience in DBT. And if you don't use DBT, how it broadly levels up the developer experience when working with data pipelines and authoring sort of the T layer of ELT. Who am I? My name is Elias. I was one of the co-founders of a company called SDF Labs. My co-founder Lucas actually went on Joe's podcast at one point. It is on Spotify. It's a very good episode. And so known Joe for a while and excited to now be representing that group of individuals, but with a different brand, which you can see on my shirt. If it's still showing on the screen, it's probably not. I am wearing a DBT Labs shirt, and that's because I now work in product at DBT Labs. Cool. So sort of going back to DBT Core, about 10 years ago, we introduced software best practices to analytics workflows. I heard a little dot. So I want to like, is there any way to, oh, I see the chat comes here.
Oh.
Yeah, it does seem like yesterday. It's something brand new. No, it's good. You just, if somebody chats, can you just say it out loud?
I will do.
Yeah, thanks. While I'm doing the deck specifically. But yeah, so 10 years ago, DBT introduced software best practices to analytics workflows, and it did this by introducing some fundamental concepts that many of us are probably familiar with, things like the model, right? Things like testing embedded as sort of as code, right? Documentation, and in general, it introduced a framework for data transformation applications, right? And there are other frameworks in different languages. TypeScript, Rust, all have these different developer frameworks. This was like sort of the first one for SQL, really, that encouraged local SQL data development for SQL-based data pipelines. And in doing that, in being that sort of first to market, it created a standard for data transformation. And this was pretty awesome. But this was nearly 10 years ago, like I said. And what has happened since? A ton of things have happened since. AI is now probably the most pressing requirement that data serves, right? We have commoditized compute offerings powered by Iceberg and shared storage formats. We have a growing and really interesting landscape of tools, both on the sort of reactive data quality side, like data catalogs and observability, and also on the sort of proactive to shift data quality and ingestion and things like that all to the left, right? And so the landscape has expanded, the requirements have changed, and the DBT Core framework hasn't taken huge leaps for, I would say, the past 4 or 5 years, mostly because the DBT team has been actively supporting this massive growing user base, right? Which sort of justifies a lack of investment in like net new, I would say, raw features. And this is totally the right call to make, but the industry, I think, hit a tipping point in the last year where it said, hey, all right, we're ready for new innovative features, cough, a new engine from DBT in order to meet the industry where it is today, to meet its moment, right? And that's why we built the new Fusion engine, which is an all new next generation engine powering DBT. It's the byproduct of combining, you could even say fusing, our technology that we developed at SDF Labs and the DBT framework rewritten in Rust, effectively, DBT rewritten in Rust. And so took those two things, smashed them together, fused them together, created this cool thing that, you know, we could honestly be sponsoring like an F1 team at this point with the branding. But it's a really, really amazing thing, and it's amazing that we accomplished it in 5 months, and to be totally honest. It is admittedly very much in beta, but what I will show you today is kind of the developer experience you can expect once it's ready to go. So what kind of things does it come with? So sort of SQL compilation at its core might be the most significant of those, right? And I'll talk a little bit more about that in a bit. But this just means that the engine understands the SQL it's working with in the same way that the database that ultimately executes the query understands it. So like we have effectively like a Snowflake compiler now running in the engine, and then also running when you run it up in Snowflake. And I'll tell you why that's really important and cool a little later, but this is an important, I think, innovation in the engine. The next part is it's rewritten in Rust, and that helps it achieve 30 times faster parse times. And we're working on these every day. So you can expect this number to go up over time, and corresponding full compile times will also get faster as we introduce smarter caching and parallelization. But even this alone, I think, is an incredible achievement just on the performance side of things. Optimize data platform costs through state awareness. And I'll talk about this a little later too. And native column level lineage. When you can understand the SQL and compile it as a part of the engine, you can suddenly understand precisely how the data flows and what happens to it at each stage. And if any of you did by chance listen to my co-founder's podcast with Joe, it was about an application of our lineage understanding at the time of sort of this classifier propagation and how we could do flexible reclassification. I think Lucas actually demoed it like 2 years ago on that podcast, which is crazy. So quite the journey. Yeah, so really summarizing the key capabilities, the key primitives that I think are worth touching on when thinking about the new engine. It's blazingly fast performance. The thing is, it really cooks. It's written in Rust. It zooms in the machine, and I'll show that in a second. It's got deep SQL comprehension at the core. And I'll talk about that, I think, in the next slide, specifically about why that's important. And then state awareness is the last one. And this is where, you know, we understand the state of the database, like we know about the freshness of the data the last time the sources were updated. And then we can skip rerunning models that don't have new data to run on, right? And so that's just one application that's can be done when you suddenly have state tracking in the system. This is really cool. Yeah. Cool. A little bit about how it works here. This will be kind of a fun detour into Techland for a second. At the core technology that we developed at SDF that is now embedded into the Fusion engine is effectively a query engine, actually, under the hood. And so on the right, you kind of have a breakdown of how a query becomes data, so to speak, right? It starts with a SQL query at the top here. We have a parser that resolves that SQL query down to a syntax tree, right? Syntax tree just has a basic understanding of the different elements of the query. So it knows that the select keyword is a SQL keyword. It knows that the column here is a column. It doesn't know the data type of that column or any semantic information or understanding about what the column is what's being done to it here, but it does know that this is a column, right? And it knows that this is a table. So we have some basic understanding at that, syntax tree layer. And then we move on to a binder here, which is this sort of compilation step where we take the syntax tree, we take in metadata about the data types of the tables being selected from, and we bind them to the syntax tree. So now we know, hey, this column is in fact, whatever, a varchar, right? Or this column is a big int. Or if the column is being transformed, like a varchar is being counted, we know that the byproduct of the count is a big integer, right? Or just an integer, depending on the database. And even if the column coming into is a varchar, we can now intelligently say, oh, okay, but the result of this count is an integer, right? And all that information turns into a logical plan. And the logical plan is that it's sort of an instruction set for the database on how to actually deal with the data and what to expect, right? And this last step of execution is where sort of optimization and planning happens. Some systems actually have optimization happen before during binding and the resolve logical plan is already optimized. But for the sake of this diagram, let's just go with this one. Optimization planning happens here and produces a physical plan, which is literal sort of like memory level instruction set on how to move the data around on a system. In distributed warehouses, it's about how many nodes to use, how to spin them up, what partitions or chunks of the data each node will process. All those wonderful details. And you might have looked at that diagram and you might be thinking, you know what, I could build that. And you know what, if you are that person, that's cool. That's awesome. Good for you. I was not that person when we started this, but and the reason I wasn't that person is because the same SQL can mean entirely different things based on the dialect, right? And when suddenly you want to scale that SQL understanding across multiple dialects, multiple databases, and you want one engine that can emulate them all, you need to have a scalable architecture that can figure out, select double quotes ABC from some table in Trino, projects the column just to the value of ABC, right? So this is like the column ABC from the table being selected from, whereas BigQuery will project this as a constant, and the result is just quotes ABC, right? And so even a simple basic select statement like this can mean entirely different things based on the engine executing it. And that is where I think the challenge is largely born, right? Is to how to create an architecture, an engine that can scale to emulate many different databases, their compilation, and ultimately even their execution. So super fun problem space. And yeah, maybe let's talk about now how this technology is applied to the developer experience and how it makes it much better. So today's ETL, ELT tools, where are they today? They typically do this. They have some local pre-processing step that takes in a raw query, or maybe it's like a query with some templating or some extra language around it, like in DBT with Jinja. It pre-processes out that templated language, and then it doesn't know if it's a valid query at that point, but sends it up to the cloud database to compile and execute it. And the error comes back down from there, as does the data, right? And the result of this is a really bogged down dev process, right? You wait minutes, hours to test and validate your pipelines as you're constantly using cloud compute just to develop and iterate, right? Not many other developer frameworks operate like this. I can't think of one off the top of my head, right? If you develop with Java or Rust or anything like that, you're just constantly staying local, right? And it's one of the foundational aspects of an evolved developer experience, in my opinion, is that locally you can emulate the large majority of what you can in the cloud. Even look at Kubernetes. You can do this with Minikube almost entirely. You can spin up like an entire backend stack of several sort of multi-node machines working in tandem with local networking. You can do that all on your laptop now. And yet in data development, we are still shipping things up to the cloud, right? And that's why the SQL understanding is so critical. Because now with SQL compilation, DBT can do this local validation and emulation, right? It can take a query, it can compile it, give you near real-time feedback on the code quality and any errors without wasting unnecessary warehouse compute, without sending and waiting for that latency, right? I think this is a pretty foundational improvement to the developer experience, and I'll show that in the demo today. Yeah. And where does this happen in DBT? Well, it happens just about everywhere, I would say. Like everywhere where you can use DBT is our goal, effectively. On the far left here, I'll be demoing the VS Code extension today, and a little bit about sort of runtime state awareness. But the VS Code extension it runs locally, right? Fusion runs locally, which is quite cool, and it can be used there. Our Studio IDE in DBT Cloud also offers this. Canvas, which is a full visual editing experience. It's like a whole GUI to be able to create SQL queries. It's really powerful, and also will be powered by Fusion. And even Insights, where analysts can come and write ad hoc queries. So this is meant to communicate just how extensible this engine is to power a variety of different developer experiences and serve different user personas, right? From highly technical to data analysts, right? This technology can foundationally improve it for most of those individuals. But yeah, let's show it. We've talked about it a lot. I'm gonna just hop back over here real quick. I did see here one ping It really cooks. Now we're yes, yes, Sam. It does cook. And let's show that. All right. How are we doing? Can you see my VS Code window? Yes, Joe? Can you see it?
Yes.
Yes? Okay, cool. So I can invoke it locally with dbtf here, right? Let's see if I do the help output. Yeah, even the help output is faster, you know? That's what I'm talking about. That's when it cooks. And the reason it's faster is because we don't have to invoke a process in the system, right? Python executables require, like, you need Python to run it. So it first goes out and calls and invokes Python in the system, and then Python runs the thing. Now we're working with a natively compiled binary. So it just, you know, the minute you write the command, it just goes. But today I'm going to show you what it's like to work a little bit with a DBT project in the Fusion engine. I have DBT Dugout locally. If any of you were at the DBT Launch Showcase in May, you've probably seen me work with this project, but worth kind of opening up and taking a look here. I have some models in this project, right? Mart's, I've got some staging models. And if we start with one of those, we can start to develop with it. But the thing I want to clarify first, and really clarify this, the Fusion engine is different from the VS Code extension. They're two different things, and they are priced very differently too. And it's worth calling that out. This thing that I'm running right here, dbtf, this is source available. You can run it locally. It's a compiled binary. There's no seat limit. There's nothing about that. You can go crazy with this thing. Deploy it in your infrastructure, do the whole 9 yards, compile, run all your models. You can do everything just like you can with DBT Core today. And I've seen a lot of a conversation about this online. So I just want to really clarify there. I can do a DBT compile here, right? I can do this for as many models as I want. I can have hundreds of people on my team do it. We're not gonna chase you down. We're not the IRS, right? This thing, the VS Code extension, which is an enhanced developer experience with powered by Fusion, this thing is a different entity and is priced differently. So we can talk about that towards the end. But what I'm going to show you today is what it's like to develop in tandem with the VS Code extension and the Fusion engine. So this is a model, staging players. I got the lineage for this model right here. Super cool lineage, staging players. It's table level. You've probably seen this in like a million apps now, but it's still, you know, always great to take a look at. We can preview this data right here, you know. Great, I got data locally. Wahoo, okay. But let's do something a little cooler. Let's look at the column lineage of the full name column. And let's talk about exactly why this visualization is super cool and being shown right now. It's being shown right now because I want you to understand just how much we now comprehend about the SQL that we're working with in this project, right? So if we look at, I'm taking a look at the full name column. And on line 17, full name is a byproduct of concatenating first name, a space, and last name. This is a completely rational transformation, right? I can't think of something more like, you look at it and you're like, oh, I know what's going on there. Yeah, we're creating a full name. And that's why we label it transformation, right? The system understands that full name here is a byproduct of transforming other columns. Whereas downstream in these other models, full name is just being passed through. It's just being selected. It's not being modified. And we know that too. That's why we label it pass through. And even one more down, when full name gets aliased to FN, we know it's a rename. So we label it accordingly. So we know all of this. We know precisely what happens to every column at each layer of the DAG. And we can power really, really cool stuff with it. And the stuff I'm going to show you today, I just want to call out too, is the tip of the iceberg. The reason we as a company are making such a fuss about this thing is because the future, the possibilities are so grand and awesome with this foundational technology. Like once you have this understanding, this metadata about the DAG and the queries you're working with, there is so much you can do in the realm of data governance and optimization and compute savings, right? In data developer experience. And so the features we launched on 5.28 are just the beginning. And yeah, I can't wait for the next few years of sort of roadmap execution on top of this foundation. But yes, let's show a little bit more about that. Pitcher salary analysis. This is the famous model that I typically do this with. So I got this CTE here called salary data. and it is selecting from a model fact, player, salaries. I can just command click to go check that out. That's how we do that. We can just command click go to ref, right? I can also hover and see what we got in salary data. We got some columns: division, full name, is pitcher, and year. And let's say I wanted to find the median. I got salary here of our pitchers by year, right? And so this is already filtering where his pitcher is true. But I do like the ability to just hover on that star and see exactly what it's selecting, so I know what to work with down below. So I'll go ahead and specify here yearly median salary is going to be our CTE. You can see Copilot is also suggesting some stuff. If I start by selecting from salary data and I save the file, boom, that's where the magic happens. Remember earlier when I said real-time feedback? That's what I mean by real-time feedback. Like the minute you save the file, it says mismatched input, pitcher details, expecting one of select table, some of these, right? We're missing a comma on line 23. And that's real time, just catching that without computing it against the warehouse or doing anything in that regard. One of our engineers has showed me a demo too of detecting this as you're authoring it too, right? Without even saving the file. Like the compiler is constantly checking it, like as you type the keys and highlighting accordingly. And it was freaking awesome. I can't demo that today, but it will one day be part of this cool system. Yeah, it kind of reminds me of with the instant SQL stuff too, right? We're all kind of coalescing in the same developer experience, which is great to see in the industry. So anyways, we're selecting all from salary data, and we specifically wanted to compute the salary year by year, right? So we'll start by selecting that year column, and we'll look at the salary. Now, specifically, I want to find the median salary. That's right. Oh, look at that. When I type, we start to get function level autocomplete. You can see descriptions of the functions here. This is the median of the column. This description was actually pulled from Snowflake and is embedded there in line as you're typing it. And we do this per dialect. When I do salary, nope, not from as. Actually, it's kind of fun. Let's like make a mistake. I was about to type that. From median salary. And then it should yell at me, right? Live demo, right? Yeah, there it goes. Yells at me. It says, hey, you can't do this. This is a parsing error because you have two froms. So now I change that to as, and we're good. Oh, but there's one more issue. Unaggregated columns in aggregation context, y'all. Must know that I'm classically missing a group by here, right? And this is a compilation error, right? To understand this, the system had to do this sort of level of analysis. And it beyond just marking this as transformation, the compiler knows that median is an aggregation function, right? And it knows precisely what this median accepts in the function signature and all that. So if I pass in another parameter here, right, like a hello world string, it'll actually fire on that first. It'll say, hey, you're misusing the median function. There's an argument type mismatch. The actual, what you've provided, is a number in a varchar, and the candidates are just a decimal, just a number input, right? Which number can cast to in Snowflake. So I can just change that, and we're back to this issue. But yeah, that's just to illustrate these sort of deeper errors we can catch all sort of in real time when we're developing. And these errors, because they're served via an LSP, which is a standard language server protocol that editors integrate with, it means that AI code editors natively get this context, right? So if I do a new line, Copilot's recommendation, which here now says group by year, is precisely correct because it got this feedback, right? Which literally says salary data.year must be aggregated or appear in a group by clause, right? And so it makes working with LLMs really, really smooth too. You probably saw this thing pop up too, this preview CTE. It is what you would expect. It is going to preview the data that just this CTE produces. The inspiration for this feature came from Jupyter Notebooks and stuff, where you can set up these sort of blocks, right? And understand exactly what the data looks like at each stage of a large-scale transformation. And I think we can start to deliver more and more like a notebook experience, but natively in a SQL query. And I think that's, in my opinion, the best combo. So if I click Preview CTE, what happens is that we see the data just the CTE produces, but we also consider the in CTE lineage. I can prove this by just command clicking salary data. It'll take me to this CTE. So that shows you we understand what CTE this is selecting from. So it runs this one first. It skips pitcher totals, and then it previews just the output of this. So super powerful feature I know a lot of folks today typically come down here and they sort of comment this whole thing out, and maybe they'll select just from that CTE. Well, now this becomes a lot simpler. You've seen a lot of these sort of go to column features. So if I command click year, it'll take me to the CTE where that year column came from. But if I do this on a completely different one, like I command click the star, that'll actually take me to where the star was selecting from. And if I do this here, we're staging players, right? It helps us just really jump around quickly in the code base and understand where everything's coming from. It's always an interesting sort of thing to ponder about, like the use case for column lineage in a developer experience. And you can visualize it, and it can be super cool to visualize, but where does it actually used? I actually think this is my favorite use case for column lineage. This isn't actually an application of column lineage. It's to be able to command click and go jump around and figure out, hey, I'm working with this data here. Where is it coming from? And what does that transformation look like? And there's a lot we can do there. And if you hover on the column, it also shows you the sort of data type and the origin right there in line too. So you don't even have to jump to it if you don't want to. So that is very cool. I think the other stuff that I like to talk about too here is that compile, the concept of a compilation, right? We're not just sort of giving feedback about one model or file at a time, right? We're not just checking to see if this file is correct as you type and change it. We're actually constantly considering all changes you make to the project in scope of the project. So that means if I take this player ID column and I show the lineage for player ID, you can see it has some downstream dependencies that are pass-throughs and that select specifically the player ID column. That means when I go adds PID here and I save that, I alias it, that breaking change is visualized on the left-hand side immediately. So I have a real-time impact analysis as I make these changes, and I can go to one of these. I can see, oh, look at that. No column player ID found, right? And if I fix using Copilot, it will probably replace it with PID. It's exactly what it did because it has context. And I just want to point out that context that it fetched was actually from, it says the available columns here are these ones, right? And it lists out all available columns, which is quite powerful. So I'll go revoke that change. And yeah, so earlier, I think, James, you asked a question about like, oh, is it not registering my SQL models? I think it's probably one of two things are happening. Either one, your DBT project is not opened in the root of the directory. So for anyone debugging this right now, it's worth calling out that the needs to be in the root code. But I actually think we may have just fixed this in the latest version. But just to be safe, I think I actually confident.
Yeah, no, it is. Yeah, it is working now and we do have our DBT project like nested in a subdirectory. So I bet that's what it was.
Ah, there you go. Fantastic. We debugged it on the call.
Mm-hmm. Yeah.
Okay, nice. Yeah, so the other part that I was going to sort of, if I were to theorize, James, it would have been that the compile wasn't working. And so this is worth calling out. This feature of like an impact analysis, super, super powerful. I can save the file. I can constantly see how my changes impact the whole thing, right? But this requires an entire compile of the project. And so if there's other issues sort of upstream of this model, right? Like if I go and do this one, right? And I go downstream to some model that's now breaking because of this. So this is breaking. And I introduce something here. This is actually worth a test. It's a parsing error, that's why. I think if I go and do team ID, right? Yeah, you see, so it will only flag this error first because our compiler stops at this point and doesn't actually get down to here. So I've seen a lot of teams struggle with this where they have a downstream model of a failing one, and they're like, oh, why is it not working? And it's like, well, because the upstream thing that this depends on is not compiling. And so it's worth flagging that this is just sort of the nature of how working with a compiler functions. It's a little different developer experience, and you have to constantly be considering your entire project context as you develop. But I will also say, I think that is a best practice, right? To always be thinking about and have the compiler tell you about how your changes impact everything else. This also works with macros. Like I have this picture check macro here. I can hover on it to see the exact SQL it produces. I can even look sort of side by side to see, it'll highlight the SQL that's produced there. And if I click on the refs, it'll also highlight those, right? So I know for me anyways, it's nice to know the fully qualified name that the ref actually resolves to. And But if I command click here, I'll go to that macro, right? And if I introduce an error here, like I misspelled true for a Boolean column, that also runs that impact analysis. So I know precisely, hey, looks like there's the SQL that this macro is producing is failing. And I can see exactly that SQL. See, oh, look, there's that true thing, that weird true thing. Or I can do this and I can go, oh, yeah, let's take a look at it. It's got the weird true thing there. And then I can hover over that and suddenly this is just good debugging is what that is. That's like, boom, right to left. We got little red squigglies telling us the problem. Yeah, I think it's quite compelling. So great, I'll save that file. We're back in a good state. Awesome. So that was really diving into the VS Code extension. There are a lot more features that I can touch on. We're done on time. We're at 37. Yeah. Joe, how long do you want to how long do you want to chat? How long should I give for us to chat?
Probably fine, up to you. We usually go about an hour, but feel free to go over if you want. Feel free to go under. There are a few questions in the chat here, which I can read out. First one's from Austin. He asks, can Rust dbtf be considered a one-for-one replacement for use of the Python dbt core? Also, are there gaps in parity or major differences in how common functions are called?
Yeah, great question, Austin. I think it was. The answer is yes, that is a goal, I would say. We deprecated some configurations and things during the transition and building out Fusion in order to improve the framework. And Core 1.10, the latest release, actually reflects those deprecations with warnings, whereas Fusion will ultimately error on those deprecations. And so we've made some changes to improve the language and framework with the new engine coming out. But in general, yeah, it's essentially a you can think of it like one-to-one port, just a lot faster and with all these new features. So it's sort of additive in that sense. And we do intend to make changes to the framework backwards compatible with Core, right? And to maybe worth calling that out, like the same commands, like I can parse this really fast, I can compile this, all these same commands work. I'll even do a build, right? All these work, the log output's a little different. And we've gotten your feedback community with a log output. We're gonna make it better and more like Core because I realize this is a slight logging regression. But all to say, yes, it does work the same way and can do the same functionalities and features. Yeah. One last call out there, sorry, before I forget. There are a few features I would say that are still in development and that we don't recommend trying out in your project. If you use a feature, I can point y'all out where to find those. If we have a chance at the end to bring up docs or something. Yeah.
Jenna has sort of a statement / question. The demo she wants to see someday, not today, but soonish, multi-project mesh development with Fusion in VS Code if possible, or at a minimum, a demo of the state-aware orchestration, the final unlock to a real DBT mesh. So
true. I totally agree, Jenna. I'm actually just thinking in my head if I can demo you a mesh thing right now. I think I can. You know, it's like one of those do it live moments. I'm tempted to, but I can. Okay, so I can certainly demo you state of orchestration. So if we just did a build, actually. This is perfect. So we just did a build, and I have this project in DBT Cloud. And because we just did a build, I know that all the data is fresh. I'm certain of that because I'm also not working with sort of streaming data, so to speak, right? So great. I have this prod environment for DBT Dugout project here, and I have a basic job and I have a state-aware job. So if I run this state-aware job, because there's no fresh data, theoretically speaking, it should not run any models actually, because none of them have new data. So let's see it. Come on. How long did that build take here? I have no way to actually determine that. Now, because I cleared my terminal. But great. Okay, that was very quick. This is a good sign. Let's see the logs here once they load real quick. I do know the orchestration team is working on this reload button, by the way, to just stream the logs. So if anyone is wondering about that. Okay, so looking at the output, you can see now we do these freshness checks, right? Last updated 1 month, 1 year ago. Great. And look at that. We're reusing all the models. None of them ran because none of them detected new data. Pretty awesome, huh? So we skipped running all of those. No compute cost incurred, no compute cost required. And the build actually ran in 4 seconds, which is pretty awesome. So that's one of the things. Let me just do a build here again so that I can show. Let's see how much faster that was. If I do a full build here, and I do rerun all these models. Let's see. Dun, 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 dun. 14 seconds. Yeah, so that's pretty good. That's about a third of the time just leveraging the cache. And this is a very small project. You can imagine how significant that gets at scale, right? And this is one of the value props I feel isn't spoken about enough with state of orchestration. It's not just a cost thing. Your data pipelines run significantly faster because they're skipping reruns. So that's cool, and it works. Yeah. Woohoo. Is there a next question, Joe?
Let's see. Abhishek, I can't pronounce your name, but the question is there documentation on how to correctly set up Fusion in VS Code?
Yeah, there is. There's a great quick start guide. Let's see. Fusion quick start DBT. Okay, it's this one. Yeah, quick start for the DBT Fusion engine. I will throw this in the chat right here.
Thank you.
Boom.
Then James has a question. I don't know if you just want to ask your question, James. I can see it on your computer.
Yep. Yeah. So when you click on like the preview CT or anything like that, where it's like actually giving you a query result, is it limiting the data somehow, or is it like going and querying the full table? Because like we have like
No,
some of our
it's
event tables and things are pretty big.
yeah. It's running a sample on this. It will
Okay.
limit the rows to 100 by default, I believe. But you can, I think, overwrite that in the settings. Yeah.
That's all good.
It's actually just like the SQL compiling under the hood is producing the query that it's actually like rendering a SQL query, and then it's passing that effectively to Fusion's version of show. That's actually what's happening.
That's cool.
And show, yeah. And show has a limit, right?
Okay.
Cool. Let me come back up here, and I'll stop presenting. If there are no other questions and no other discussion to be had, I can try to scrap together a mesh demo, but I have no guarantees that'll work.
I have one while you're scrapping that together. So I know some of the governance features are some of the things y'all haven't implemented yet, but is model versioning in yet?
Model versioning's in, yeah.
Okay. Cool.
It does work. Good question.
Let's try and scrap together a live demo. That'd be,
I shouldn't have offered it.
this is
signing up for
the community, right? I think everyone will empathize with you if it works or it doesn't work, and yeah, live dangerously.
Live dangerously. Give me 1 second to find the right project for this. Docs internal.
I can keep asking you questions if it's not too distracting while you're.
Yeah, go for it, James. Yeah, of course.
So I know, or I believe one of the other things y'all are working on is like a DBT like linter and formatter. Like right now, like the Cloud CLI uses SQL Fluff, or like other folks might just use SQL Fluff directly, but that's part of like, I guess, the roadmap for Fusion as well, right? Is like a Fusion native linter and formatter. Is there anything you can give us?
Yeah, so we have an issue for this that we're tracking. But in general, so the complexity of the linter at STF, we had a linter as a part of the compiler, and it was awesome and super fast and all this stuff. And also just trying to set this up in the background. The roadmap for that isn't exactly fully ironed out yet. Like I wouldn't say it's absolutely certain when we'll launch it, but we know we want to do it. I would say it's not crazy to think like within the next 6 to 12 months it would get in there. And the complexity of it is honestly in building SQL Fluff parity so that the migration is very simple and you can reuse that config. It's actually not in the linter. The linter is like pretty much done for most of the dialects we support. So
Right.
that's the funny part about that. Yeah. Okay, working on this here. Let's see how we do. Okay. I'm actually seeing if I can get this working for one of our internal projects. I don't know if I don't know if that's totally kosher, but I think it'll be kind of fun. Got it. Is that a cross project graph? Let's see. Yeah, these are all cross project graphs.
Is it
Yeah.
bidirectional project dependencies?
I don't think this demo is bidirectional. This is one downstream project.
It's the bidirectional that I'm really curious to see working with the state-aware orchestration. Because that's what
Oh, interesting.
orchestrating bidirectional projects was
Yeah.
not possible.
Yes, that is certainly a challenge. I don't think I can show that with this project in particular. But I can show you just like a local compile. Is maybe the best I can do. Okay, yeah, here you go. So check it out. So I have this model here, and yeah, this is pretty good. Cool. So this model is doing a bunch of cross-project refs. See all these? Oh, yeah, like this one. Cross-project refs, right? And we're surfacing compile errors here because there's no column present in the cross-project mesh context. So what's happening under the hood here is if I do a compile, some errors will show up, but at some point you will see this extending, right? And this is where we actually pull down the publication artifact reference. It says cross-project refs there, right? And what we're getting here is we're getting essentially a list of all the models available in the upstream project. And then we're getting their fully qualified names so we can go fetch their schemas from remote when we compile. And we can actually statically verify that you are selecting columns that exist in that cross-project context. So in this case, it's actually detecting that I'm selecting a column that does not exist in a different project, right? And you can imagine going the other direction too, where if you make a change, we can tell you if it breaks something in a downstream project as well, if it violates a contract, or if it's even just used in one of those downstream columns. And so, not the sexiest demo, but it does work, you know? Yeah. Any questions?
I have one not about this, but do you have any suggestions or pointers for getting, like Cursor or Claude Code or something to use DBT Fusion properly?
Do I have suggestions or pointers? It just works kind of actually. Like I have Cursor right here, and you can install the extension. Yeah. And
so as long as so once the extension's installed, like it just knows to use it. Like I don't need to like add a cursor rule or put something into my Claude Markdown file or
cursor rule. You just need to install that DBT extension right here. Yeah. Yeah, pretty cool.
Yeah, nice.
There was a demo that I did of this. If I can get it working here. I did used to have it working. It was essentially just an agentic demo of it, like developing with the compiler, because the sort of key with AI development is just how fast it can iterate and validate that the code that it spit out and potentially hallucinated is correct or not, right? Both from a semantic and syntactic standpoint, but also from a logical standpoint. And there was a cool demo that I could do with that. Let's see. Where are my past chats? Why did I just clear my whole context of this thing? I actually use Cursor. That's why you see so many windows open. So that's like my default editor, ironically. I'm sort of building myself up here for like no drop because I can't actually find where this project was. But at some point, I think I have a video of it that I'm happy to share with the community of me.
Yeah, that'd be beautiful.
Yeah. That is what I will do.
Just drop it in the
Which
Discord.
product you use? Yeah, I'll drop in the Discord, definitely. For sure. Cool.
So, can you give us an idea of what's coming up or what's next?
Yeah. What's coming up? What's next? So we are just racing towards preview, being able to call this preview and then being able to call it GA. That's really it. It's a beta right now. We don't support. We're still developing support for all the features in DBT. A lot of the more nuanced, less used ones, right? So James brought up governed models before. That's a good example of one. Yeah, the road is long there. Like it's a very extensive framework, I would say. But we feel really confident in our ability to do it. It's just sort of a matter of like time and physics, you know. Like, can the engineers just sit down and write the code to support all of the features in this framework? And we're getting there. And at some point in the next year, we'll be able to confidently say this works for all DBT projects, and it's going to be awesome. One of the big callouts is this month we're launching the Redshift adapter, which is going to be great. So Redshift projects will be supported in the beta. And yeah, it is generally available. I will well, sorry, generally available. Like you can install it. It's generally available. We wouldn't call it GA. You know what I mean? GA is a name we use for products that were like yeah. I got you with links. Wait 1 second. This is gonna be our Fusion engine. Install Fusion. So that's right here. The idea of long tail is for looking less commonly used adapters. Yeah, I was just talking to Lucas about this last night, who's the sort of engineering counterpart on the Fusion side. We are, Spark is up next in the priority list for sure. And then we are talking about DuckDB. It's going to be sick. And that is the most upvoted issue in the on our repo, like by a long shot. Like if you go and actually, let's see, if you go to DBT Fusion, right, go to issues and you, no, not new issue. You sort by reactions, total reactions. Yeah, DuckDB adapter, top of the one by far. Look at that. People just love this thing. Just lots of hearts actually. Whereas like this one about supporting CLI credentials has an enormous discussion around it. But people are hearting this DuckDB one. So you know what? We will listen to the community and we will give them what they want. That's going to be a crazy experience too, like compile time feedback and then just DuckDB iteration. And then ClickHouse is also one we've been actively discussing. So yeah, at some point we'll get them all. You know, this is our new foundation. We're going to build everything on top of it. We're super excited to. Athena also comes up as another one that's a priority that we're discussing actively. Yeah, I hope that gets at the question, Jenna. Like the short answer is like we're going to get to them all. That's the sense of the ones we're thinking about in the immediate. Yeah.
Yeah, the collision of like instant SQL with Fusion is going to be an interesting one too. Because as you were typing earlier, I was like, yeah, these are very, very close. It's just funny how, like you said, everything's sort of converging on the same problem space, which is just trying to run everything on the cloud server. So.
Yeah, exactly. And I would say the biggest thing that differentiates us in that capacity is that we support all databases, right? Like that's a DuckDB specific feature because DuckDB is so fast. But we can bring that same instant SQL-like developer experience to every database, Snowflake, BigQuery, Redshift, right? All the big ones. Yeah.
It's really needed. Yeah, ClickHouse, like James said, that's blown up a ton.
It's crazy.
Yeah.
They're a fantastic team. All the good stuff.
Yeah.
Jenna, were you going to ask something? Oh, yeah. Here's the plan for now. Develop our adapters, really big community development as well. I think there will be community development as well. The challenge we find with a native executable binary is that it has to be signed, right, by our DBT lab signature, essentially, in order for the core binary to talk to the adapters, right? So they're dynamically linked in the system, and if they don't have the same signature, then Mac OS will be like, "Hey, you're trying to run like some sketchy software that we haven't validated is okay for Mac computers," right? When we sign it with the Mac signature, we're telling Mac OS and Apple, "Hey, you know who we are. We're DBT, and you know where this executable came from. You can trust us," right? And so the way community adapters would support or would work, I think, in this paradigm would be we'd have like an open slot in the repo to sort of contribute them. We would distribute the adapters on DBT package hub, actually. And then we would sort of link a ADBC driver, which is similar to ODBC, JDBC, but Arrow native. And that's an open source entirely Apache 2 repo, ADBC is. And so you'd be contributing open source code, essentially. It would just be a few more steps to actually get it to work and be deployed like the Fusion engine is, so that we could sign it and macOS won't yell at us.
Yeah, I was gonna say, like, y'all are actually doing a ton of ADBC development for all of this, right? And like contributing it back upstream. So like
we are upstreaming a ton of that. It's been awesome working with some of those teams. I want to call out like the Columnar team. They're like an awesome team that spun out of Voltron, and they're building a ton of great ADBC drivers. And I think there's some of the founders of ADBC, I'm pretty sure, like Matt and others. Ian and Matt.
Yeah. So like that could be another way for like the community adapters will ultimately need to like have an ADBC driver. So like that's probably what it turns into, is something a little lower level than what a lot of the adapters are for DBT core.
Yeah, that's exactly right. James. Yeah.
Cool. I think we're at time, unless anyone has any other questions. But thanks a ton, Elias. Give him a round of applause. It was great. So and I guess to kind of close out, for people watching this on YouTube or elsewhere, if they wanted to learn more about Fusion, what's the best way to do that?
We have an awesome webpage that I did not design. Which is to say it's beautiful and really well done, and I would have done a way worse job. And it is, if you go to dbt.com, and it's under, hold on, I should know this better. A second. Which one is it? If you just look up DBT Fusion on Google, it comes up as like the second one, but I'm going to put it in the chat here. The full URL is dbt.com/product/fusion, and it's the right starting place. It's got this frickin' sweet animation again that I did not create. No credit to take here, but it's the right starting place, and it's pointing to the docs too if you actually want to install it. I'll send the slides in the Discord, and I'll send that video of me using the compiler with cursor, because that is a lot of fun. That's a ride,
That's cool. Well, thanks. I'll stop recording here, and thanks a ton, Elias, and the DBT team for setting this up here. So.